Okay, one last one. Are you sort of getting the hang of this? It's this table here that you got to know by heart, sort of thing.
Could you do, if you're making a graph for f double prime, can you just use the same rules? Like how you make a graph for f prime off f, can you use the same rules for f double prime off f prime?
Exactly. That's the other underlying thing, that f double prime to f prime is the same as f prime is to f. Yeah. That's a good instinct to have. So here's an interesting function known as logistic curve. And it's kind of like a model for population growth, in which it says that, okay, you have a population, it starts off initially like you expect population growth to go, but after a while it stops exponential growth because you got limited food, resources, that sort of stuff. And so then it flattens off and you get this kind of S shape and kind of flattens here. Okay. And so what can you tell me about f prime? It's positive because it's always increasing. So population is always increasing. Okay. What about f double prime? Right, it starts positive and then it becomes negative. And then, so at some point here, 0. These kind of things are called, does anyone know the name for them? It's called an inflection point. When you're studying something, inflection points are useful things to talk about. It refers to some kind of, something's happening that's causing this. So it's some sort of changing point. So here we're going from exponential growth to growth restricted by resources. So that's what causes that inflection point. And it's like the point where things are growing the fastest. After that, things grow more slowly. Okay, so you're used to questions, graphical questions, where you just think about slope and concavity. What happens if we have a numerical question? Okay, so let me give you a table. So this is number of vegetarians on in a dorm. Okay, so we go to 1989, sorry for the whole data. 1991, 1993, 1995. 7, 9, 2001. 3, 5, 9, 10, 23, 33, 37. Okay. So we're interested in V. Okay, so V is the quantity, it's the number. What can you tell me about V prime? It's positive, and why is that? It's increasing. Exactly the same kind of thing that you observed with the graph. You can say that V prime, V prime is positive. Okay, so what can we do? Well, so one of the things we can do is we can plot we can figure out V prime. Okay, there's kind of different ways we can do this. Let's figure out what V prime is at the in-between, the even years. The reason why we do that is because we can get good, because it's a nice short interval, right? And so it goes up 2 in 2 years. So the derivative is 1. It goes up 4 in 2 years. The derivative is 2. Goes up 1 in 2 years, a half. Oop, goes up 13 in 2 years, that's 6.5. Goes up 10, it's 5. Goes up 4, that's 2. Okay, and so we can do kind of the same kind of thing with V double prime. And so now we can do the odd years again. It goes up 1 in 2 years, so that's a half. It goes 1.5, so that's minus 3/4. Goes up 6, 3. Goes down 1.5. So that's minus 3/4, and it goes down minus 1.5. Okay, so that's a little bit more confusing. It's not a real clear signal that we get. So what can we say? So we can see. So that what are interesting things? So this 3 here is interesting. And so what does that mean? What does that tell us about the data? There's a big acceleration. So V prime is always positive, but we can see around 1995 there was a big acceleration in that. And again, we can, because we've got a rise which is kind of unusual, doesn't kind of fit the trend. So most of the time it seems concave down, which means this trend is slowing down, except in 1995 when the trend went up. Okay. So this is just some kind of data analysis we're doing just by looking at the numbers. But the fact is, we can figure out V double prime from V because we just look at the differences of the differences. And you can tell it starts to get a bit uncomfortable, how trustworthy it is. It's kind of hard to get a clear signal, but this is a nice clear signal here. This means something happened here. Whereas afterwards, it seems like around 1995, we had like a big surge. And then afterwards, that's slowed down. That would be how you would describe it. Okay. Lastly, it's going to be formulas. And life is going to be easier for us after when we do the next chapter, because we'll actually learn formulas for differentiating formulas. But let's have a look at x cubed divided by 3. So did we do this as a homework problem, or did we do it in class or something like that? So when we did it, oh, hang on, we did x to the 4th on 4th. That was the homework problem, right? And what was the answer that people got? Anyone get an answer? Oh, let's do something simpler then. Let's do x squared on 2, because that's a nice, easy thing. Okay, so let's try and guess a formula for f prime of x. Okay, so we could start off with x being 0, 1, 2, 3, 4. F of x is 0, 1/2, 2, 4.5, 8. Okay, and if we look at f prime of x, we can see that we get what? 2 divided by 2 is 1. Here we get 4.5 minus 1/2 is 4. 4 divided by 2 is 2. 8 minus 2 is 6. Divided by 2 is 3. We do 5. We get 12.5. 12.5 minus 4.5 is 8. Divided by 2 is 4. Anyone like to make a guess what f prime of x is? Yeah. Later on, we'll see why that is. Okay, and so what's f double prime of x then? What's the slope of 1? Oh, what's the slope of x? 1. Okay. Okay, so that was a simple example, but we can do the same thing with more complicated examples. So first off, you start off with f of x, and by a table you can come up with f prime of x, and another one for f double prime of x. So if we do f double prime of x, right, we get 3 minus 1 divided by 2, 4 minus 2, etc. We all get a bunch of ones there whenever we do the difference quotient. Okay. That's the difference quotient. Yeah. Like that. Oh, here we go. Where are my books? Oh, there. Can you get them, Jimmy? Just put them there. Very important job. Okay. Okay, here's some questions for us. Today's the 27th, right? So Matt,
Yep.
this one here. So here we've got a function there.
Yeah.
So which one of these 5 statements is true? So there's allowed to be more than one.
A, B, C, and F. Or sorry, not F. I mean D.
D. Okay. Is F always positive? What?
Oh no, it goes under. Sorry.
Oh,
I said the wrong letters. My bad. It's B, C, and I think E.
so let's have a look. Is F increasing? It is. Is F prime positive? So what does F prime positive mean? It's getting steeper. Is it getting steeper? So B is true, C is true. Is F prime increasing? F is, oh, hang on, F prime being positive is kind of the same as F increasing. So B and C actually are the same thing, right? D, is F prime increasing? It is, it's getting steeper. And is F double prime non-negative? Yeah, because F prime is increasing, that is true. So the answer was actually B, C, D, and E. Joe, is Joe here?
Yeah.
What about this statement here? True or false? If F prime is positive, then F double prime is increasing.
False.
False, yeah. So just because F prime is positive, F double prime can do anything. Okay, that's true. Hannah, there. If F prime is increasing, then F is increasing. True or false? Let's have a look. Let's have a look. I think of that. So F prime increasing just means it's getting steeper. But here we could have something like this, right? Where it starts off really negative and it's becoming less negative. So in this one here, F prime is increasing, but is F increasing? No, doesn't follow that way. So you've got to be careful about which way the implications go. Oops. Max, if F double prime is positive, then F is concave up.
True.
Yep. Because if F double prime is positive, that means F prime is increasing, and that's what we need for concave up. Eric, if F double prime is positive, then F prime is increasing.
True.
Yep. When a derivative is positive, that means the thing before it is increasing. Peyton, if f prime is increasing, then f is concave up.
I think it could be true, but I don't think I don't think f of x has to be concave up for f prime to be increasing.
So if f prime is increasing, what does that? If f prime is increasing, well, that means it's getting steeper, right? So if f prime is positive, it's going to look like, it's going to get like this. And if it starts off negative and it's increasing, it's going to look like this. So is that concave up? Yeah, that is true. Ellie, if the velocity of an object is constant, then the acceleration is 0. True. So what's this to do with derivatives? Well, it's like a velocity is like a first derivative and an acceleration is like a second derivative. So if the velocity is constant, that means it's kind of flat. That's the second derivative is 0. But also it's just from physics that you should know that, like if you're just going at the same speed, then your acceleration is 0. Is that it? Are we done for the day? Everyone packed up, so I assume that I have to watch. Yes, it is. Okay. See you Monday. Have a good weekend. You have a good weekend too. Oh, goodness, I had one. So there are a lot more questions like that that are on Blackboard that you can have a look at. Sorry? Oh, I cannot see you. I'm sorry. That's naughty of me.